السلام عليكم طلبتنا الأعزاء. Our lecture today will be about an important subject, which is the bile acid metabolism. Bile acid is an important substance that are produced by the liver. The objective of this lecture is to discuss the bile acid synthetic pathway. We will also list the type of the bile acid, the primary and secondary bile acid, and the difference between them. And we will state the enterohepatic circulation, which are very important for bile acid metabolism, and how the bile acid are modified, and how the synthesis and their level is regulated, and the homeostasis remain constant and in a normal way. And in addition, we will correlate clinically with some condition that may result from deficiency of bile acid. Bile is a fluid that is made in the liver, and it is mainly composed of water. About 95 to 98% of the bile is water, and other constituents that are important is the bile salt or bile acid, which are the topic of our lecture today, and also the bile contain bilirubin and contain lipid, which are the cholesterol, fatty acid, and lecithin. The two pigments of the bile are bilirubin, which is an orange-yellow pigment, and the other one is biliverdin, which is green. The biological role of the bile acid or salts that is found in the bile is to facilitate the fat digestion by emulsifying them. So by emulsifying them, the fat, it will increase the surface area of the material for the pancreatic enzyme. Emulsification means that we convert the substance that is water insoluble to water soluble. By doing this, we will increase the absorption capacity of this material by the intestine. Bile acids are usually synthesized from a precursor, which is the cholesterol, and the synthesis occurs in the liver. After they are synthesized, they are transported to be stored in the gallbladder in a concentrated form. After a meal, the gallbladder will contract and the bile will flow into the duodenum. About 95% of these bile acids that are secreted into the small intestine will be transported back to the liver from the distal part of the ileum and from the colon by what's called the enterohepatic circulation, while the remaining 5% of the bile will be excreted in the feces, and this will provide a route for getting rid of the excess cholesterol, because when the body senses that there is decrease in the amount of bile acid, it will synthesize it from cholesterol, so the amount of cholesterol will be decreased by using it in synthesis of bile acid. We have many pathways for the synthesis of bile acid. We have the classical pathway, and we have the other pathway, which is the alternative pathway. In addition to the role of bile acid in solubilization of the fat and allowing it to be absorbed readily by the intestine, it provides a mean for getting rid of the excess cholesterol from the body. The synthesis mainly occurs in the liver. It requires about 17 enzymes, and usually it occurs in the cytoplasm, in the endoplasmic reticulum, and in the mitochondria. We have the classical pathway for synthesis of bile acids, and we have the alternative pathway. These two pathways occur in the liver. The major pathway is the classic or the neutral pathway, and it involves, usually we start from cholesterol. All pathways start from cholesterol. Usually there will be hydroxylation in the classic pathway or the neutral pathway. There is a hydroxylation of cholesterol at the position 7 by the cholesterol 7 alpha hydroxylase enzyme. So we have the cholesterol will be hydroxylated at the position 7 to form 7 alpha hydroxycholesterol, and the enzyme is the cholesterol 7 alpha hydroxylase. This enzyme is member of the cytochrome P450 family of the metabolic enzyme. The other pathway, which is the minor pathway, we call it the acidic alternative pathway or the acidic pathway, in which the cholesterol will be hydroxylated at position 27 to form the 27 hydroxycholesterol, and this is done by the enzyme cholesterol 27 hydroxylase, and later on it will be hydroxylated by at the position 7, and it will form by a lot of steps, both the alternative pathway and the classic pathway. Finally will form the primary bile salt, which are the primary bile acid, which are the cholic acid and cholic. So the bile acid, we have the primary bile acid starting from cholesterol, either by the classic pathway, which is the major pathway, or the alternative pathway, which is the acidic pathway. Start from hydroxylation of cholesterol at different position, but eventually both of them lead to the formation of what's called the cholic acid and the cholic acid. These are called the primary bile acid. To make these, before they are conjugated into the bile, they undergo conjugated process with amino acid, either with the amino acid glycine or taurine. So the cholic acid may bind to either glycine or taurine, and the cholic also bind to either the glycine and taurine. When they are binded to these amino acids, they are converted to what is called primary bile salt. They were acid, and after conjugation they became salt. What are the purpose or the benefit of getting conjugated and converted to the bile salt? The benefit is that they became more excretable or easily secretable into the bile. The gene that encode the enzyme responsible for the steps in the bile acid synthesis must be, or they are already under tight control. Why? Because the metabolite of the bile acid are cytotoxic, so the excess amount may damage the cell. So this is the liver. From cholesterol, cholic acid and cholic acid is formed by the controlling enzyme. Then they are converted to a primary bile salt and then stored in the gallbladder. After a meal, by the action of cholecystokinin, the gallbladder will contract and release its content into the intestine. What happened in the intestine? These are deconjugated and the amino acid taurine or glycine are removed, and then by the from these primary bile acid, and then these bile acids are acted upon by a certain type of intestinal bacteria, and then it will be converted to another type of acid, bile acid, which are called the secondary bile acid. They are called the secondary bile acid are of two types also. We have the from the cholic, we have the cholic acid, we have the deoxycholic acid, and we have from the deoxycholic, we have the lithocholic acid, lithocholate or the lithocholic acid. So the primary bile acid in the liver, in the intestine, are converted to the secondary bile acid, and most of it will be reabsorbed again in the intestine. The process of secretion of the bile from the liver, then to the gallbladder, then from the gallbladder to the intestine, and finally reabsorption of this bile acid again back to the liver is called the enterohepatic circulation. This process, the bile acid pool regeneration or recycling, occur about 4 to 14 times a day. So it is recycled many times during the day, and some of it, about 95%, is reabsorbed and 5% is lost. This 5% that is lost in the feces will be compensated by the de novo liver synthesis of the bile acid. So if we have, we try to do interruption of the enterohepatic circulation by, for example, a certain medication that bind to bile acid and allow more percentage to be secreted in the feces, this will help to decrease the amount of the bile acid and represent an effective strategy to treatment of hypercholesteremia, because the body will sense that the pool of the bile acid will decrease, and it will be compensated by synthesis of bile acid synthesized from cholesterol. This will lead eventually to decrease the level of cholesterol. So we have the primary bile acid are cholic and chenodeoxycholic. The percentage of them, the chenodeoxycholic form about 45% of the total, and the cholic acid is 31%, and they are conjugated to form the bile salt, followed in the intestine. After they stored in the gallbladder, then after contraction, after a meal, there will be secretion into the intestine, and then in the intestine, they first will be deconjugated from the amino acid, and then there will be, by the action of bacteria, they will be converted to the secondary bile acid, which are the lithocholate and the deoxycholate. Bile acids are toxic, and they are cytotoxic, so their concentration must be tightly controlled. We have a special type of receptor, nuclear receptor, that is called farnesoid receptor. It is very important in the metabolic pathway. The bile acid and bile acid metabolite will bind to this receptor and activate the transcriptional activity of this receptor, which is the farnesoid receptor. It can sense the concentration, the amount of the bile acids, and also it helps to prevent the cytotoxic effect of the excess amount of bile acid. In addition to its major role of the bile acid as a lipid solubilizer or emulsifier, they have other action. They are important as part of the lipid metabolism and glucose metabolism. They give signaling molecule, a signaling pathway. They can control it for liver regeneration, and also it affects the overall energy expenditure. Initially, they was thought as its role only for lipid solubilization. Now, with more research, they found that it have many roles, for metabolism, for example, the lipid, the glucose, and for energy metabolism in general. So bile acids are important in addition to their roles in emulsification and proper absorption of fat and fat-soluble vitamin. The bile acids are important for energy balance, for tissue remodeling, important to carry signal for liver regeneration, immune homeostasis. It is important for electrolyte balance, hormone secretion. It is important for transcription, for cellular metabolism, and even for normal gut microbiome. So if we have bile acid deficiency for any cause, all of these functions are affected. What causes the bile acid to be deficit? What are the cause of low bile acid? First of all, the synthesis may be impaired in case we have a defect in the liver, in case the hepatocytes are distorted, as in case of cirrhosis. The hepatocyte cannot synthesize the bile acid. The liver are the main site for the synthesis of bile acid, or it is the exclusively it is synthesized in the liver. If there is obstruction in the common bile duct that prevent the flow of bile acid and the bile from the liver to the intestine, also we will have bile acid deficiency, and in this case the fat absorption will be impaired, and the fat soluble vitamin also may be impaired. And sometimes when there is a defect in the intestine that prevent the enterohepatic circulation, the absorption of the bile acid conjugate from the terminal ileum, and the enterohepatic recycling of the bile and bile acid in case of any disease affecting the terminal ileum. Also, this will lead to decrease in the level of the bile acid, and this will lead to decrease in the absorption of fat, malabsorption of fat and fat-soluble vitamin. There will be deficiency of vitamin A, D, E, and K, and the symptoms of their deficiency will be evident. And also, in case there is any defect in the portal blood, so that it cannot carry the bile acid to the liver, or when there is disease in the liver cell, so that they cannot extract the bile acid from the portal circulation and re-secrete it again into the bile. Any disease that affects the hepatocyte may prevent its normal functioning as an extractor of the bile acid from the portal circulation and secrete it again in the into the bile, as in case of hepatic cirrhosis. So the defect in bile acid and malabsorption of fat and fat-soluble vitamin either occur secondary to decrease in the synthesis of the bile acid when the hepatocytes are defective, or when there is obstruction to the flow of the bile from the liver to the duodenum, or when there is a defect in the intestine, so that the absorption of the bile acid is impaired, and whenever we have disease in the terminal ileum, which is the site of reabsorption, as in case of resection or Crohn's disease or any disease affect the terminal ileum, it will lead to deficiency of bile acid and malabsorption of fat, or sometimes again when there is a defect in the liver cell that prevent them from extraction of bile acid from the portal blood and resecrete it again into the bile. So what happened in this case? We have malabsorption of fat and fat-soluble vitamins A, D, and E, and K. There will be also abdominal tightness and sometimes diarrhea. Secretory diarrhea also will result from bile acid deficiency. One of the causes of decreased synthesis of the bile acid is when we have inborn error of metabolism of bile acid. This may be due either to the defect in the enzyme that are required in the process of conversion of cholesterol to the bile acid, or it may be secondary to any other defect in the substrate that are required to convert the cholesterol to bile acid other than the enzyme. If the cause of the defect is deficiency or decrease in the enzyme that are necessary to convert the cholesterol to the final product, which is bile acid, we call it a primary disorder. If the defect is also metabolic and affect the primary bile acid synthesis, but not due to the synthesizing enzyme, we call it secondary bile acid disorder, which is also inborn error of metabolism. So inborn error of bile acid metabolism is an example of decrease in the synthesis of bile acid that will lead to decrease in the bile acid and eventually lead to decrease in absorption of fat. It is of two types, either primary due to defect in the enzyme that are important for synthesizing bile acid, or secondary due to other metabolic defect that is important for synthesizing primary bile acid, but not the enzyme. What happens if we have inborn error of bile acid synthesis? If it is usually it appears during infancy, then there will be a cholestatic liver disease. And if it is a milder case in which it may appear during childhood and or even in adult life, then there will be a neurological disease, progressive neurological disease. Also, there will be cholestatic liver disease in addition to the neurological disease. The cholestatic liver disease that occur secondary to inborn error of bile acid synthesis during infancy is characterized by jaundice. When we check for the level of bilirubin, there will be hyperbilirubinemia, and it is usually of the conjugated type. And there is increase in the level of the transaminase, the AST and ALT enzyme, and normal GGT. And in addition, there will be clinical features suggestive of vitamin A deficiency, D, E, and K, which are lipid-soluble enzyme. While in adult life, the neurological manifestation of bile acid synthesis defect, there will be sign of upper motor neuron lesion, which is spastic paraparesis, and both the cholestatic liver disease and the neurological disease that occurs secondary to inborn error of bile acid synthesis may be treated by giving him synthetic bile acid replacement therapy. We give him bile acid, both of them responds very well, so it is very important to diagnose it as early as possible. And we can diagnose the condition of inborn error of bile acid synthesis by taking urine sample, and we check for the level of the urine colloids, which are the bile acid and bile alcohol. Another disease that is linked to bile is the cholesterol gallstone. When the bile became supersaturated with cholesterol, it may precipitate, and if this precipitation increase with time, it may form a gallbladder stone, which may be single or multiple, and it is not related to hypercholesteremia. It is unrelated to the hypercholesteremia in the blood. It depends on when the bile is supersaturated with cholesterol. Usually it is more common in obese individual, and it may be single or multiple, and its color is either white or yellow. So in summary for this lecture, bile acid is the major constituent and the most important factor in solubilizing the dietary fat and fat-soluble vitamin. It's required for proper digestion and absorption of lipid. And it is synthesized in the liver, stored in the gallbladder, And when there is a diet, there will be a stimulation of the hormone cholecystokinin, and the bile will be released to the duodenum, and it will solubilize the lipid and lipid-soluble vitamin. And the most significant, or the bile acid that is present in higher concentration, is a higher percentage, is the echinodeoxycholic acid, which will form about 45%, and then the cholic acid, which will form about 31%. Both are the primary bile acid. Before they are secreted to the bile canaliculi, they are conjugated with amino acid to make them more secretable. They are either with the glycine or taurine. In the intestine, they will be deconjugated and the amino acid will be removed, and by the action of bacteria they are converted to the secondary bile acid, and when they reach the ileum they will be reabsorbed again by the enterohepatic circulation, and 5% will be lost in the feces, and this 5% will be replaced by de novo synthesis by the liver. And there is a certain treatment that increase the amount that is lost in the feces, so that as a compensatory mechanism, the liver will synthesize more bile acid from cholesterol. So as a modality of the treatment of hypercholesteremia is by this way. Defect in the enzyme of the bile acid metabolism, secondary to defect in liver, result in liver dysfunction and cirrhosis, progressive jaundice, and fatty diarrhea, which is called also steatorrhea. And thank you, and ready for any question.